Physics Bites,
Physics Bites,
a science podcast in English by the students of Notre Dame d'Ascension.
Hello and welcome to Physics Bites, the English language physics podcast of the students of Notre Dame d'Ascension here in Paris. We have a new episode today on forensic science and two new students in our senior class who are going to introduce themselves.
Hello, my name is Lola and I'm in Terminal.
So we have Lola, who has been a student of mine since last year, and...
Hello, my name is Pauline and I'm in Terminal 2.
Pauline, who's been a student of mine for the last 2 years. So, within the framework of our senior class, you guys had a little topic to pick relating to physics, and you guys chose to do something quite original. You wanted to do something on forensic science and the physics, basically, at the hands of the police and police work, which in the last 3 or 4 years I have not had, so it was very interesting. I learned a lot of things. There was a certain TV police investigation aspect to it, which was fun. So how about I let you guys begin by giving a short introduction to what you guys talked about, maybe some of the topics that you covered, and then maybe we'll go into a few details as we go over that. Do you want to start, Lola?
Yeah. So we talked about forensic sciences and basically how physics can help the police to solve crimes and murders. We talked about how forensic science is basically based on the principle that it's impossible for criminals to escape a crime scene without leaving behind traces of evidence that can be used to identify them. And we insisted on the fact that forensic science needs to be as precise as possible and have legitimate data, so it could be evidence that's presented in court. And we went over a few better known aspects of forensic science. We analyzed and developed on a few methods that maybe Pauline can talk about.
Mm-hmm. So if we want to sort of make the link to physics, the idea is that by using principles of physics, whether it's the way fluids work or the way, for example, movement can be modeled using, Newtonian laws of mechanics and all these things, anything that you would find at a crime scene can be analyzed using principles coming from physics mainly, and that could give us information which in the end would be enough to find out either who did it, how they did it, and other sort of logistic aspects. Is that it?
Yeah, exactly. Forensic science is based on physics and a lot of other sciences. Mm-hmm. But yeah, mostly physics and physics properties that...
So from the notes I took from your presentation, you talked about various topics, pH analysis, ballistic analysis, a lot of spectroscopy, talked a fair bit about blood pattern and splatter analysis, fingerprints, and all these other things. So what do you guys want to talk about? Maybe we do a little tour of the topic and you just give me a short idea behind each of these techniques. So maybe we can let Pauline begin with the topic of her choice.
Yes, we can maybe start with spectroscopy. So it was like one of the big subjects that I talked about. It's basically like the interaction between matter and electromagnetic radiation. Mm-hmm. So it's based on like the idea that each substance absorbs or emits light at a specific wavelength, depending on its atomic or molecular structure. So this interaction can tell us a lot of things about what type of blood is, if there was blood on the scene, or what type of substance there was on the crime scene to detect maybe something that is unusual. And with this,
just so we can be clear on the idea behind spectroscopy, it is basically the study of different kinds of spectra or light, or in any case using light to make a sort of a diagnostic about something. You mentioned 2 or 3 different types of spectroscopy. Do you want to maybe give us a little bit of detail about what they are and how they're used, each of them, in a forensic setting?
Well, there are the UV vision spectroscopy. So, like, the UV vision is about UV, so it's not like the light that you are normally supposed to see. And first, you have to analyze. Well, you have the substances that you haven't seen yet. So you're gonna put the UV lamp on the substance, and you're gonna try to you're gonna detect the substance, and according to so its absorption of this light, you can put the light and the absorption on a graph, and according to the graph, you're gonna detect according to the nanometers if it corresponds to a certain substance like blood or I don't know, coffee or something like that.
Okay, so the idea being that by looking at the spectra of different substances, you can detect the nature of the substances that are present. So you can figure out, okay, so in the crime scene we have this, but we also have this, and those can be clues that could help us get a better idea of what happened in the crime scene.
Yes.
Okay. Lola, do you want to talk about one of the other techniques that you guys brought up in the presentation?
Yeah, one of my favorite things that I researched were how fingerprints and how the fingerprints that are found on crime scenes can help. It can tell us a lot about like how the victim moved in the space, how the suspect maybe conducted the crime, if any witnesses were there.
Right, so fingerprints is an old classic in the sense that so we've been using fingerprint analysis for many, many years. So outside of just detecting the shape of the fingerprint and then figuring out who it might belong to, you guys went a lot further, much more analysis of what kind of fingerprints we have. Do you want to maybe give us a bit of detail about the physics of fingerprint analysis?
Yeah, of course. So like you said, fingerprints have always been around. It have always been something that forensic science can rely on, even if the techniques to analyze them have always improved. We basically have two types of fingerprints. We have patent and latent. Patent fingerprints are fingerprints that are already visible on the crime scene. So they can either be fingerprints on soft surfaces like soap or fresh paint, or we have just patent fingerprints because the fingerprint is bloody or maybe with ink, and then we have latent fingerprints that are invisible, and that's where a lot of physics is used because we need to discover them and be able to analyze them.
Do you want to maybe give us, I don't know if you guys found this during the research, some more, some physics of how some of this might work? Something that might be more modern and less old-fashioned, where you would be dusting, a surface to see what the fingerprint looks like, and maybe even once we have the fingerprint, how we can link that to somebody, or you talked about using light sources, or different substances that we can use to detect the presence of certain atoms or elements.
Yes, so the way that we have been finding fingerprints has been changing, and one main problem that we used to have before, when you mentioned dusting, was basically touching the crime scene and making it like showing new information on the crime scene that can maybe be a problem if we want to have the original. Like, if we want nothing touched, that's not the easiest method. So we have discovered alternative light sources, and it's basically a way of pointing a certain type of spectra, a certain type of light on the fingerprints and helping it appear. The color of the light is going to impact how clearly certain fingerprints are seen. Mm-hmm. We also have, like, for example, amido black. It's a way of, it's like a protein stain that basically, it's a non-specific protein stain, so it reacts to the protein that we might see. So if for example there's like a bit of blood or a bit of natural matter, we will be able to put amido black, which is like a physics concentrated method, and the fingerprints will appear. We have also used like machines that use zinc and gold. These are called vacuum metal disposition machines, and you basically put an object that supposedly has fingerprints on it into a machine that kind of very, very lightly puts a mix of gold and zinc on it, and so fingerprints appear. And one last but quite important way that physics have evolved and has managed to use fingerprint is accutrans, and it's this liquid solution, this casting compound that you can basically put in textured surfaces where it's going to be hard to find a fingerprint, and it's going to solidify, and then you can basically peel it off and you have the fingerprint on it. So those are all examples of how science and physics help get more precise data.
I learned an interesting thing. You told us in France, in order to use a fingerprint to consider somebody a suspect, you have to have at least 12 instances of it at the crime scene. Is that it?
Yes, exactly.
I had no idea. In the movies and in the TV series, you always see one fingerprint and that's enough and the guy goes to jail. But no, in real life, we admit that there's so many fingerprints because so many people are everywhere and touching everything that it's not, it's necessary but not sufficient. Okay.
Yeah, exactly.
So let's go to Pauline. You had a big bit about ballistic analysis. Do you want to maybe tell us what we mean by ballistic analysis and tell us how physics is essential for that, for detecting, getting clues when it comes to what happens at a crime scene?
Yes, well, ballistic analysis is like really important forensic science because it's basically what we use to analyze the path of a projectile, like a bullet, a rifle, or a pistol, and you can thus understand its impact and identify weapons used in a crime. So basically, you're gonna study the impact of a bullet if you can't find it in the crime scene, and you're gonna understand from where the shot has been done, or taken, or from or which how many power there was in the gun, and then you can deduce.
Okay.
How
do you want to maybe tell us where the physics in there is? Like why is this such a particularly sort of a physics-based thing? Where is the physics of ballistic analysis? Where is that coming from? Which part of physics is it that's most concerned by that?
Well, it's mostly about the fact that it uses principles of dynamics and of Newton's law with the air resistance and gravity, and the force that is involved in it with if the force is equal to if the force is equal to the mass and the acceleration of a projectile.
The famous second law of Newton, which is one of the most important tools we have in physics for quite a few centuries. So you're saying that basically what we call ballistic analysis is the perfect application of the laws of mechanics as we learned it even in high school.
Yes.
Okay. And what does that allow us to determine about what happened at the crime scene? How does it help us maybe get a better idea who might have been the criminal?
By using these laws, you can first identify the firearm that was used. So, if I'm starting with the fact that each gun is going to leave some markings on the bullets, and so if you can find the bullet in the body or on the wall, you can find you can identify these marks that were made. So I know that, for example, like if you have spiral grooves inside the like the barrel
bullet.
of the yeah, like if there is like if there is spiral grooves on the bullet or this like characteristics, it allows the forensic experts to like match a bullet to some other bullet, so that you can identify if there was many guns that were used, or if there was only one, if there was like many people that were on the crime scene, or only one person that was shooting everyone. And it also permits to determine the shooter's position, so their position and their shape. It's the angle of fire help determine their position or the shape of the person.
Okay.
And if there is like if the bullet bounces off a surface,
Right.
like its path can be traced, and thanks to like you can use like laser technology or stringing techniques, like you can trace the bullet's path by to estimate the shooter's
So basically anything that tells us precise information about the way a bullet moved, where it came from, will allow us to get a better idea. So the idea would be to recreate sort of what happens at the crime scene, which is one of the most important things if you want to figure out who did it, for what reasons, how, etc.
Yes.
Okay. Maybe we can come back to Lola, who had one of the more, let's call it visual parts of the presentation, when you talked about blood patterns and splatter analysis, something which I think became famous in our popular culture with the TV show Dexter, who was a blood splatter analysis. So it was interesting to find out that this is an actual thing. Do you want to talk to us about it a bit?
Yes, so it very much is an actual thing. It's basically lets us understand a lot about like what went down, how the blood was shed is an indicator of how the crime was basically made. It can tell us a lot about the victim, how hurt they were, if perhaps the subject got hurt, got blood on their hands. Same thing for the witness. We can know if any narcotics were involved or poison. And it's basically, you talked about how it was important. It kind of is popular in TV shows. That's true. But we kind of need to keep in mind that it's not by looking at a few blood spatters that we can understand just exactly what went down. It's a precise science, but it's also very meticulous work. And a lot of physics definitely goes in. You can't just... I mean, sometimes we see like absolute experts or geniuses just figure out everything, and that's just not the case. Yeah. So we talked about how different types of physics properties can impact how the blood is seen on the crime scene. We talked about the fact that blood spatters could either be from projectile expulsion of the blood when an artery is ruptured, and so it's going to either bleed out. Yes.
Give us a little bit of details. So, for example, just as basic biological thing, we know that, for example, if an artery is cut, as opposed to a vein, the way the blood gushes out is much more powerful because it's higher pressure. Whether somebody is shot, for example, you said if they're standing, if they're sitting, if it's shot at an angle, all of this shows up in the blood splatter. Can you go into some details, maybe to talk to us about why that is the case? What are the physics involved, but I guess just the idea of give us a little crash course in blood pattern analysis.
Of course. So basically, blood pattern analysis really depends on the violence of the event, and that's how it can help us understand what went down. So the velocity of the blood kind of shows a lot. We have, for example, low velocity, and that's we can see that if there are like tiny specks of blood on the crime scene, and that's going to be if a weapon fell out or was cast off. It's going to leave little spatters of blood, but nothing incredibly violent. We have medium velocity, and this is going to be like a blunt force, stabbing, and the surfaces that are going to be near the body part that was stabbed. There's going to be like this big part of this big like spatter of blood, and then droplets that are progressively going to get smaller as we move away from the body part. And then we have high velocity, and that's gunshots, and you'll generally have on a crime scene a little hole where the bullet was, and then all around it tiny specks of blood that are like even smaller than a drop of blood. And this just shows that this was a really violent event, and that a gunshot went down.
So the idea, I guess, being that the force that expulses the blood would, because of the laws of fluid mechanics, change the shape of those droplets, change the shape that they would make when they hit a surface, whether it's a wall or a floor, and that by looking at that shape, we can sort of reconstruct the causes. We can say if it was like somebody got stabbed, or if it was a gunshot, or if they were hit with a baseball bat or something like that.
Yeah, exactly. But other factors are also involved, like the angle at which the violent event occurred. We can, like, the type of surface also matters. A lot of other factors can make the blood spatter appear like it does.
Okay. So, and this is something that is, would you say it's like more recent, or is it something that has been used for a long time in forensic analysis?
So I would say that forensic science is a really, like, quite an old science, and we've always seen blood on crime scenes. I think it just got more and more sophisticated, but of course, if you see like a giant puddle of blood, you can understand that that's where the victim was lying. If you see bloody fingerprints, like, it's always been something that you can understand with the naked eye. It just got fancier, I guess, with time.
More precise, more technical, and
yes.
So you're basically saying that Dexter is real. Okay, that's good. All right. Pauline, one of the topics you talked about was also relating to, I suppose, liquids, but more chemistry than physics. You talked about pH analysis. Do you want to just give us a very brief overview of what pH analysis is and how it helps police work?
Yes, of course. Well, pH plays an important role in forensic science, as it helps forensic experts to analyze substances found at crime scenes. So it's like using not the same method as spectroscopy, but the result is finding new substances and helping analyzing them. So it helps and determine potential evidence and identify unknown materials. For example, identify bodily fluids like blood, saliva, sweat, or even urine. And like, for example, if you have a substance that you can't identify, well, if the pH is like around 7.35 or 7.45, you can it like may indicate blood. And if a sample deviates like significantly, it may indicate that it's decomposition or contamination, and so try new hypotheses and new ways of leading the researches. And like also if you like search for the urine, I think it's like between 4.5 and 8, and so it's depending on the diet and on the health of the person. So if the person was sick or using drugs,
or if like had alcohol in the blood or was given some sort of a poison, I suppose.
So you can have some of the consequences or like a context of their deaths, and like you can even like maybe determine the time of the death, because the pH of the body fluids will change due to like bacterial activity and the reactions in the body. So also if like the pH of the muscles drops, it's means maybe that as lactic acid in the muscles will accumulate. That means that the pH drops, so it means that maybe the person is dead or for a long time. And so you can also analyze unknown substances like drugs, poisons, or even chemicals, and because they have a specific pH that can be tested. If, for example, there is cyanide on the crime scene or in the body,
which is a very strong poison.
Yes, it's it has a high pH, so it's an alkaline solution, and so you can identify through pH testing. And so in drug analysis, you will certainly use pH to detect the presence of certain illicit substances.
Okay.
And yes.
So in a general way, pH analysis specifically, and I guess chemical analysis of whether it's fluids we might find at the body, in the body of a victim, or even, and you were talking about surfaces, the soil, etc. Basically, it allows us to determine the presence or absence of certain molecules, certain substances, which could give us a lot of information in our reconstruction of what is happening during the time of the crime. Okay.
Yes.
So maybe I think we talk about one last technique, I think, Lola, that you brought up towards the end of your presentation, which was forensic facial reconstruction. Do you want to talk to us about that a little bit? I imagine that this is one of the more modern techniques.
Yes, it is, even though it actually has evolved since it started in the 80s. It basically is a process of recreating the face of an individual from their skeletal remains. So this is used when a victim is found after a long period of time after their death, and we only have their skulls left. And we kind of reconstruct what their face looked like so the victims can be identified. Because what we might not realize is that every single skull is unique, and the shape and the size of our skulls determine our appearance. So basically, they're used to identify the victims, and this happens, for example, in mass disasters, or when there were maybe there was a fire and the victim is just unrecognizable. This is used in forensic science. It's also used in archaeology. It's basically a way of finding very old skulls and understanding what the people looked like at that time.
So it's the same technique that we use in archaeology for, by looking at maybe the remnants of a skull to see what, some predecessor of the human species looked like. We're using the same techniques, if necessary, for a crime scene, whether it's because a victim is badly disfigured or something like that.
Exactly. And it is a science, even though it's a bit controversial.
How so?
Because in both cases, facial reconstructions can be a bit less accurate. Yes, so basically a lot of art has to be used because the people that are doing facial reconstructions are scientists, they are experts, but they are also artists, because based on the skull, you need to understand how the tissues of skin basically layered to have our face, and that can sometimes be just a bit less accurate. We have two types of facial reconstruction, and the accuracy kind of depends on the technique. Mm-hmm. We have 2D reconstruction, and so basically you have a photo of the skull once it's been scanned and put into a lab, and based on that you have to make a drawing that's supposed to look like the victim, and then we can compare the drawing to the different kind of victims. But we have been improving the science, and 3D reconstruction is very much in the field now. It's either used when a skull is printed out, it's 3D printed, and then people can use clay to basically layer the tissues of the skin and have an actual skin. Or more recently, softwares have been developed that manually kind of digitally sculpt the skull.
Yep.
And this is thanks to scanned images and photos that are put into the software that can then create a face.
Okay. So that seems interesting. Potentially promising if you want to find out who the person is, which is not always necessarily easy given the amount of evidence remaining. Okay, so I think that was a pretty good way of going over most of this stuff. I had a question. I suppose that we are at an age now where AI is going to be insinuating itself into everything. Did you guys in your researchers found anything that talked about the way we're using modern artificial intelligence to help with the forensic analysis, or not really?
AI is useful in everywhere possible, but I know that, for example, it's really efficient with crime scene analysis, because it may not like reconstruct like everything in detail, but it can like scan and using like 3D imaging, it can help detectives to like stimulate events or predict like trajectories like bullet paths, and so using like ballistics too, and like determine like what really happened, or maybe have an idea of what happened, so that the scientists don't go in the wrong path when they're doing their researches.
Okay.
But I know that, well, in facial recognition and reconstruction, it can also be really useful, because it can maybe like create all of the faces that are possible to make. So I think like there's a lot of uses in AI. That's what I read when I was doing my researches.
I suppose it is going to be something that is going to find its uses more and more, as it does in pretty much everything these days. Another question I had for you guys, which was something that I think we already touched on, and that's the question of the accuracy of these different methods. Because if we're going to be using these results in a court of law, and we're potentially going to be maybe condemning somebody to jail time, lifetime in jail, maybe in some countries to death, we would need to be pretty sure of them. What are, in general, the accuracy of these different techniques? Are there some which are much more safe and much more sure than others? Are they generally pretty accurate? Not really? Just, what did you guys find in the research that you did?
Okay, for the accuracy, I know that it's based on science, so most of scientists and just detectives believe in these techniques, but doing like some researches, I know that there is like highly accurate forensic techniques depending on the techniques. And for example, the DNA analysis or like toxicology is considered as high accuracy, because it uses advanced methods, spectroscopy or chromatography, and so it is like techniques that are really developed and always like evaluate, always like growing in our world. So it's not a new technique, so it's really easy to know if it's accurate or not. And the more modern forensic science can have like some error rates, but like the lie detector, I think it's like something that came not a long time ago, like in the 20th century. And so it measures like psychological responses, like the heart rate, the sweating or the breathing, and like the accuracy is like around 60 to 70%.
But I suppose the problem with that is that there's the problem is not, I suppose, in the accuracy of the measurements we make, but the interpretation of that, which is more, I suppose, other, I guess, domains, more psychology, maybe psychiatry or other things than actual physics, right? Whereas, as you said, a DNA analysis or pH or chemical analysis is very accurate. So we know with very close to 100% certitude that, for example, such and such chemical elements are present, or the DNA matches to 97% or something like that. Okay. Lola, did you have anything to add to the question of accuracy of these results, conclusions from the various methods, how it's seen today in a more legal sort of framework and stuff like that? Did you come across anything when you were researching?
So I'm completely with Pauline on the fact that the older sciences are and the more developed, the more accurate.
Right.
Actually, this with what you asked us earlier, how I saw I'm pretty sure it was not university, talked about how sometimes AI can help enhance the data that we already have. Like, it helped enhance image and clarity of video evidence.
Right.
That's something that has been evolving. That's something that changes a bit in forensic science. It basically, the more technology we have, the more it can improve the level of detection and the accuracy of any forensic science.
That is a very good point. I think you're right in that. Maybe it's not necessarily new techniques which are the key, but improving the accuracy of existing techniques that we have to the point that they become almost certitudes. Okay. Is there anything that you guys wanted to bring up that we haven't talked about, or are we good?
I think I'm good.
Maybe
we talked a bit about...
I was going to say one final question, maybe. Which would be maybe related to where you guys are in life at the moment, is how does one get into forensic science? Is it basically you're trained as a scientist, physicist, chemist, and then you go to the police and investigation side of things, or is it something apart?
So basically, a lot of people start off with either degrees in biology or physics, and I think that if you want to specialize in that field, that then it's not but you're going to be really performing in... Can you hear me?
Yeah, it's getting cut. It occasionally gets cut off.
Hello?
Yeah, we can hear you.
Oh, I'm sorry.
It's okay. Finish your thought.
I was just saying that you're not going to have a degree in forensic science, but basically if you have a degree in biology and you want to get into the field, you're going to learn while in the work space,
so
and
like
then kind of become a forensic scientist.
But you're trained as a scientist to begin with.
Yes, because it's this like niche kind of field that isn't that mainstream.
Okay. So in case any of your classmates are looking to get into forensic science and become investigators, well, they're going to have to do science first. All right. So maybe we can finish off with just one final question. Personally, for you guys, how did you find your topic? Did you find it interesting? Did you discover things that you didn't know? Was there a lot of stuff that were confirmed? Just like a general, how was the work? Maybe we can start with Pauline.
Sorry. Well, I think that was really interesting to look at the techniques in forensic science and just discover that, like, I know that in many movies that we can see when we're in the court, it's about testimonies and confessions about the criminals, but seeing that in the backstage there's a lot of things and a lot of chemical principles that are involved, of physics principles that are involved. I think that was really interesting, and the understanding that even the smallest part in a crime scene can be an evidence that can lead to finding out who is the criminal, or if there was many people, is kind of really fascinating. And I really like doing my researches because I could see that all of the things that are related to forensic sciences are related to what we are studying in high school. So it was understandable, and I really like this part.
So I guess it makes
That
it
part.
also sort of interesting, the idea that you could potentially project from what you're studying, which is kind of abstract and theoretical, to some sort of a real life application.
Yes.
Okay.
Yes.
Lola, did you? What's your overall opinion of the topic that you guys picked out and the research you did, stuff you learned?
For my part, because I'm not studying physics at all, I had no clue that much physics was involved in forensic science. I didn't know that so many different sciences were involved. So it was really interesting to me because this is not something that I usually study, and I found that the different subjects that we learned about were really interesting. It was really interesting to research. There's a lot of information on the internet. I didn't think that it was such an important field, but it is, and it was really interesting. I really liked it.
That's cool. That's cool. All right. Well, Lola, Pauline, thank you very much. You guys had it was an original presentation you guys did. It was not a topic we usually see, so it was good to change it up a little bit compared to some of the more very purely theoretical topics. You guys did a really good job. I think we all learned a lot, so thank you very much. So, that is Physics Bites for this week. We hope that you enjoyed this episode, and we would love to hear what you thought about the topic in the comments section. If you did enjoy the show, then subscribe to our podcast, share it with your friends, and be sure to leave us a 5-star rating on whatever platform you're listening on. And more important than all of that, come back soon for a new episode.